The jamming of the signals by the Russian troops was so effective that Ukraine, as well as the United States and NATO, could no longer assume that the Joint Direct Attack Munition or JDAM smart bombs and other smart weapons would hit their targets. That's the conclusion of an analysis by Britain's Royal United Services Institute, or RUSI. Jamming does not cause the JDAM to stop working, but risks its accuracy, according to RUSI researcher Thomas Withington. While an anti-jamming upgrade to JDAM can mitigate the problem, Russian electronic warfare systems can easily suppress GPS guidance signals from satellites. The problem may be the tolerable strength of the interference signal, Withington said. The warning comes after a Pentagon document leaked in April revealed concerns that Russian interference reduced the accuracy of American guided weapons, including the JDAM and HIMARS rockets. The effect on JDAM was significant, as it is arguably the simplest and most cost-effective of all smart bombs. By fitting the fins and GPSS guidance system on cheap old-fashioned dumb bombs, Ukraine can produce long-range guided weapons at a fraction of the cost of special precision-guided munitions, which are in limited supply. The JDAM extended range bombs delivered to Ukraine reportedly have a range of up to 50 miles, allowing the gliders to remain safely out of range of Russian air defenses. The GPS-guided munitions initially offered Ukraine hope of offsetting Russia's superiority in manpower and firepower. Indeed, HIMARS will prove pivotal in Ukraine's limited counteroffensive in the summer of 2022, when rockets destroy the Russian base and supply stockpiles. That Russia is developing countermeasures should come as no surprise. All weapons eventually lose their effectiveness as the enemy adapts. It's no secret that the Russian military, like its Soviet predecessor, is putting great effort into developing various electronic warfare systems. Specifically, Withington points to the Russian Army's R-330 Jiven, a mobile truck-mounted jamming system designed specifically to disrupt GPS and satellite communications in the 100 MHz to 2 GHz band. The signal from the United States GPS satellite, used by the JDAM tool, is transmitted in the band from 1.164 GHz to 1.575 GHz, according to Worthington. It fell right inside the catchment area of the R-330Z, he said. Worthington claims to have seen official documents that put the R-330Z's range at 18.6 miles, with a jamming signal of 10 kilowatts. This is stronger than the strength of the GPS signal coming from outer space, he said again. In addition, the closer the GPS receiver is to the R-330Z jamming antenna, the stronger the jamming signal will be, he added. In theory, the Selective Availability Anti-Spoofing Module upgraded to JDAM in the early 2000s should ensure that JDAM will only respond to official M-code encrypted military GPS signals. However, Withington said, the Russian jamming system may still be able to interfere with signals through beam jamming, namely brute force. The Russians were also able to intercept the M-code signal and retransmit it with slight changes to JDAM, causing the bombs to miss. Attempts to bypass Russian interference by using signals from multiple GPS satellites can in turn be overcome by using multiple jammers. Russia's GPS counter-efforts are part of a massive electronic warfare campaign that has also disrupted Ukrainian radio communications and drone operations. Russian troops are now using about one main EW system per 10 kilometers of the front, usually located about 7 kilometers of the front, according to a recent RUSI report on Russian tactics. This signal jamming has contributed to RUSI's expected loss rate of Ukrainian drones, up to 10,000 UAV per month. According to the RUSI report, Russian electronic forces are also highly capable of intercepting and decrypting Ukrainian radio communications. In one case, they appeared to intercept and decode encrypted radio messages from Ukrainian forces calling out fire missions in real time, allowing Russian commanders to send preemptive alerts to their units. Nonetheless, Russian electronic warfare has limitations. Emitting jamming beams reveals the jammer's location, and the Ukrainians appear to have located and destroyed Russian systems, such as the R-330Z. Ironically, blocking the airwaves with a powerful jamming beam could also disrupt Russian GPS and radio communications. The Russian constellation GLONASS-GNSS transmits several signals similar to GPS, Withington said. There is evidence that the Russian army regularly suffered electromagnetic fratricide for this purpose. The troop often showed little concern for interfering with friendly signals when engaging its enemy.